Hi guys, and welcome to this, my video on finance applications using arithmetic sequences and recurrence relations. These titles don't get any shorter with the new study design. My name is Darren from Maths Guru. Thanks very much for joining me. Hopefully what you're about to watch will absolutely make sense and help you continue to smash maths, or at least start smashing maths. Before I get started, do me a favor, can you head over to YouTube and click that subscribe button? That really will mean the world to me. Why? Because it just lets me know that people are watching. I don't actually get to know otherwise, and so people who subscribe just let me know that they're watching. And also, believe it or not, I'm on TikTok. Yes, can you believe it? 147 and I'm on TikTok. Now, what we're going to do by the end of this lesson, as I say every single time, is I'm going to run through what hopefully by the end we need to know. We're going to be able to use a recurrence relation to model simple interest. Now, that might be a new thing this year for you guys to ever have heard about. Flat rate depreciation, that's certainly going to be new. Unit cost depreciation, and to understand how to use a rule for the nth term for linear growth or decay. So again, linear means a straight line. We've talked about that in previous videos. So we're going to start bringing this all together. All the learning we've had before, we're going to start bringing together. But all we're going to do now is try and confuse you with stupid language. And finance has its own stupid language. Let's not rush ahead of ourselves. Right, so as I say, in previous lesson, we know what a recurrence relationship. If you remember, a recurrence relationship is something like V0 equals 20, V of n plus 1 is equal to V of n plus 10. So for example, there we go, we've got a start number 20. To get to my next term, I'm going to take my current term and I'm going to add 10 every single time. Right, now again, because I'm just adding 10, this will give me a linear growth. All right, so there we're already starting to put things together. We've seen that, we've drawn the graphs, we know what a recurrence relation is, we know what a rule is. A rule will be something like V of n equals V0 plus n times d for linear growth, right? Where we got whatever number, whatever term number we want, 20 terms, 30th, the 40th, 100th, we know that n there would be 100, for example. We take our first term and we add n lots of our common difference. Now, this is making no sense to you whatsoever. Go back and watch the videos. They're on mathsguru.com. Download the notes. It's all free to sign up, yada, yada, yada. It's there to help you. You can pre-learn, post-learn. If you get stuck, go back and watch the video again. Now, it's all been really theoretical, hasn't it? Because if I look at this thing here, what does that actually mean in real life? Well, this is now going to start turning financial. All right, so as I say here, we've had the recurrence relation formula. I've just done a bit of a recap. Let's do it again. This is for your summary book if you need to know it. T0, that is my first term. A was my start number, right? And a sequence has to start somewhere. T of n plus 1, my next term, is given by my current term plus my common difference. Now think about going to a bank and opening a bank account, and I put some money in, and then every single month I pay my wages in. Let's assume I get paid $1,000 a month. $1,000 a month, then every single month, theoretically speaking, if there was no interest whatsoever, then this D there would be 1,000 and I get $1,000 more every single month. That would be linear, okay? But basically, maths tries to trick us. So if you think about it here, if we look at it here, we had T0 and T of n plus 1. Now, finance tends to use V or N or whatever letter that the maths people want to use. So you've got to realize that basically we can use any letter we like here, but you have to be consistent. So again, P. What on earth is P? Well, for maths, when you take out a loan, when you put money in a bank account, whatever else, it's called the principal, right? So the principal amount is the capital P. And again, this D here may be, I don't know, some sort of supplementary payment being added. Maybe I'm paying into a bank account. Maybe I'm paying off a loan. Now, the weird thing is, you know, the government want you to be able to be more financially literate. I get it. But then we start talking about loans and interest and compound interest and flat rate depreciation, all things that I don't even think your parents in many cases should have any clue. But we'll just keep going. Now, welcome to simple interest. Simple interest is the biggest con on the planet, all right? So I don't know anywhere that pays simple interest because some banks would lose a lot of money. But the general idea of simple interest is this. I would open a bank account with, say, $1,000. Now, that interest account is going to be paid interest at a certain percentage. So it may well be that my interest is 10%. That means every single year I will get 10% of what I started with. And that's the really important point here. It's all done on the percentage of what I started with. So if I wanted to work out what 10% of 1,000 is, That's 10 divided by 100 times by 1,000, which gives me 100. So that would give me $100. Now, simple interest in that situation means that from then on, every single year, I would earn just another $100. Now, do you see there's a bit of a problem with this one? Because you're not getting interest on the interest. You're getting one fixed amount of interest. What if you close the bank account? Are they still going to give you $100? It's random. Simple interest, weird. But the point of it is, you will get a fixed amount of interest per year from now to eternity. Okay, so keeping that in mind, this here will be my simple interest. That would be the value of the interest being added on. And P would be the amount I open my bank account. So maybe $1,000, and in that situation that would be $100. Being able to read these things is really, really important. Now, I gave an example a moment ago of what was it, $1,000 at 10% interest. But what if I had $2,000 at 8% interest, or $4,000 at 1.2% interest? Right? We got to come up with a consistent way of working out what would my simple interest be. What is 10% of 1,000? Well, in that situation, we worked out it was 100. How did we do it? Well, we took the interest rate, we divided it by 100, that's what percent means, and then we times it by our initial amount. How would I find 8% of something? Well, I would do 8 divided by 100 times by initial amount. What about 1.2%? Again, I'd do 1.2 divided by 100 times 4,000. So this is my initial amount, otherwise known as V0. Here is V0. This is my rate of interest. Let's call it R. There is my R, and my percent divided by 100. So whoa, thank you very much. We now have a formula that I can use to find my simple interest, regardless of what I pay in and the rate of interest. So it's now important to know that when you see this formula here, P is going to be my initial interest, my initial value, how much I put in there, my loan, my investment, whatever else. D can now be worked out using this formula here, and they will always give you the rate of interest and the initial amount of the investment. So let's have a go. Right, what have we got here? An investment of $3,500. So the first thing I know is V0 is 3,500. It pays interest at a rate of 4.2% per annum. 4.2% per annum just means per year. We'll get into that later, in the form of simple interest. Now, if I was doing this in an exam, I'd be highlighting simple interest so my brain knows. Find the amount of interest paid per year. All right, so once I know the interest paid per year, well, if we remember, that's simply finding the value of D. Okay, well, we can do that. So my D is going to become R, 4.2, divided by 100, times my initial investment, or my amount of 3,500. Now, I don't know about you, can't do that in my head. So I'm going to fire up my TI Inspire. I'm going to add a calculator screen there, and let's do, oops, not that one. 4.2 divided by 100. And I'm going to times that, if you will, by 3,500. Gives me $147. So again, because this is simple interest, that would suggest that every single year I will be getting $147 in interest. Doesn't really work like that, but ka-ching. The following recurrence relation can be used to model a simple interest investment of $2,000. There we go, so at $2,000, paying interest at a rate of 7.5% per annum. So we now know from this equation that V0, they gave me that, is 2,000, but our value of R was 7.5. So my question I have to you now, and if you can read these things, you should be able to work out, what on earth is this 150? Well, hold on a moment, that's the interest, isn't it? So actually, in this situation here, they've already done the hard work for me. They found 7.5% of $2,000. But what I'm going to do is I'm just going to check 7.5 divided by 100 times 2,000. Fire up my calculator again. What is it? 7.5. Sorry guys, I'm having to stretch. Divided by 100 times by, what did I say? 2123. Hit enter. And there we go, $150. So being able to read this and understand that that now is actually my simple interest makes life a little bit easier. So having understood the question, what does it ask? Use the recurrence relation to find the value of the investment after 1, 2, and 3 years. Now, here is a big hint for a VCE exam. You have to show you're working. It's a 1-mark question, but it will require, in this situation, 4 lines of working. I'm going to show you what I mean by the working. First thing you're going to write down is V0 is $2,000. The next thing you're going to do is you're going to write down V1 is $2,000 plus 150. Remember, our thing says to get to my next term, take my current term and add 150. So when I do that on my calculator, I get 2,150. My V2. Now this is what I mean by the working out. You can't now just do 2,150 plus 150, 2,300. You have to write it down. Sorry, what I mean is, speaking and talking at the same time, not very good at. You cannot just write down the answer, all right? So for those of you who are like, that's so unfair, I get it. Trust me, I do. But if you don't do it, you're not going to get the marks in the exam. And trust me, your study score will plummet in general maths. V3 gives me 2,300 plus 150 gives me 2,450. Now, realistically speaking, I should put dollars in there because I am dealing with money, and ka-ching, there's the first part of the question. When will the investment reach $2,750 in value? Well, actually, I'm going to fire up my calculator now, because if you've been watching the previous videos, you know I can actually use my calculator to do all the hard work for me. So I'll put 2,000 in. Now I'm going to do my answer plus 150, and I'm going to hit it once. So that's at the end of one year, 2 years, 3 years, 4 years, 5 years. So after 5 years. So that's the answer to the first dot point. The second dot point is simply 5 years. In that situation, you wouldn't need to show any working out. You would just use your calculator to do the hard work for you. Now, flat rate depreciation, another strange terminology, but it's all good, it's fine. When something depreciates, it goes down. So interest always gets added on. When something depreciates, it always goes down. But what I'm going to tell you now is the formula stays pretty much exactly the same. I get this D is equal to R on 100 times V0. That's the amount it's going to go down. But because it's flat, it means it's going to stay the same. And so the only difference between my previous formula is that minus sign, right? So depreciation, there is a minus sign there. Interest, it would be a plus, but the same now for the rest of the question. Flat rate depreciation. And to be fair, this type of thing should really go in your summary book, yeah? Just so that you know the difference. The following recurrence relation can be used to model the flat rate depreciation of a car purchased for $18,500. There we go, so there's my V0, 18,500. Depreciating at a flat rate of 10% per year. But hold on a moment, once again, where did I get this 1850? Well, again, they've done the hard work for me. They've worked out 10% of 18,500. So 10% of 18,500 would be, if I did that in my calculator, 1,850. So that means that my car is going to lose $1,850 every single year. And the recurrence relation, Vn, is the value of a car after n years, right? So that's also important that it is n years. Use the recurrence relation to find the value of the car after 3 years. So again, V0 is equal to 18500. V1 is 18500 minus 1850. And again, I definitely can't do that in my head, so I'm just going to do this. But I'm going to be a bit clever now. I'm going to use my calculator and go 18500. Put that in my ANS. So ANS now minus 1850. And there we go. So I get 16650. V2 is going to be 16650 minus 1850, which equals 14800. And V3 is 14800 minus 1850. And again, that gives me 12950. So after 3 years, my car is going to be worth $12,950. How long will it take for the car's value to depreciate to zero? Well, okay, we got all the hard work on my screen there, yeah? So that was after 3 years. 4, 5, 6, 7, 8, 9, 10. Right there. So after 10 years. And if you want to know what I was doing there, I was just pressing the enter key. Once you've got the ANS minus 1850, every time you hit enter, it just does the same calculation for you, yeah? Easy peasy lemon squeezy. Unit cost depreciation. Now again, this is Barry just messing with your head. A unit cost depreciation basically is exactly the same as flat rate depreciation. Look, if you look at this formula here, what do you notice? It's exactly the same. All we have now is that D stands for the unit cost, right? Or how much it depreciates per unit. And to give a real world example, a photocopier basically loses money every time you take a photocopy, right? So we'll spend 50,000 on it, and then for every copy that we print, the school are going to lose money, and at the end of it, it's not going to be worth anything. So the point here is exactly the same formula. Now, for unit cost depreciation, generally speaking, we probably don't need that. I think the value of D will be given to you, but if it isn't, we can probably work it out. So a car with a purchase price of $3,200, so V0 is $32,000, depreciates at a unit cost of $150 per 1,000 kilometers. So for every 1,000 kilometers, it's going to lose $150. Okay. State the recurrence relation for unit cost depreciation of the car, where Vn represents the value of the car after n thousand kilometers. Right, so every 1,000 kilometers, right? Because it's saying every 1,000 kilometers, we're losing $150. So in which case, my recurrence relationship must start with 32,000. I've got to put that comma. It has to have V of n plus 1 equals V of n. And I am losing, so it's minus $150 for every 1,000 kilometers. Believe it or not, in a VCAR exam, that is worth 2 marks. Use the recurrence relation to find the value of the car after 1,000, 2,000, and 3,000 kilometers. Whew. Okay, so 1,000, 2,000, and 3,000 kilometers after n thousand kilometers. State the recurrence relation. I'm just thinking about this question now. State the recurrence relation for unit cost depreciation of the car where Vn represents the value of the car after n thousand kilometers. N thousand kilometers. Yeah, leave it at that. Right. Use the recurrence relation to find the value of the car after 1,000, 2,000, and 3,000 kilometers. So in which case V0 would be 32000. V1 would be 32000 minus 150. And again, not doing that in my head, so let's be smart about this. 32,123 minus 150. Hit enter. Gives me 31,850. V2, 31,850 minus 150 equals 31,700. And V3, which after 3,000 kilometers would be 31,700 minus 150, which gives me a grand total of $31,550. And again, I'm going to put those dollar signs in just because I can. How many kilometers is the car expected to travel before its value depreciates by at least 1,000 kilometers? Well, I've done 3,000, so I'm going to hit enter. 4,000, 5,000, 6,000, 7,000 kilometers. Now, how did I know it was 7,000 kilometers? Well, my car started at 32,000. I want to see when is the first time it gets down to 31,000. Well, it doesn't get down to 31,000, it gets down to 30,970. 950 in fact, and so in which case my correct answer there would be after 7,000 kilometers. Now again, these questions are you just interpreting and reading what's being done. Right, now we're going to change recurrence relation into rule. We've done this in a previous lesson. We're going to try it and do exactly the same thing here. So first things first, a recurrence relationship always has V0 in it. It has some value here, a comma, and then it has V of n plus 1 equals V of n, and then either some plus value of D or minus value of D. And just to let you know, that plus, minus on top of each other basically is a great way of letting us write two equations in one. So our rule, if you remember before, will become V of n is equal to, now we can say P or we can say V0 plus or minus n times D. All right, so yeah, that's the shortcut. That's where we're going to get to for you to be able to know this. Yeah, really, really important. But I'm not going to explain it. I'm just going to tell you it. So hopefully you're going to realize, as we've done before, that whatever this value of D is here is the value of D there. Whatever the value of V0 is there is the value of V0 there. Okay, so that being done, let's see. We've got our recurrence relationship. What does it say? The example following recurrence relation can be used to model a simple interest investment of $4,000. So it says simple interest. I'm going to say simple interest. Paying interest rate at 6.5% per year. Okay, 6.5% per year. Where's this $260 come from? Again, they've done the hard work for me. They've worked out 6.5 times 4,000. So I'm just going to write that down. 6.5 divided by 100 times 4,000 will be $260. Right, so that's good. So a simple interest, that's going to get added on each time. How much interest is added to the investment each year? We know that. So the first dot point is $260. That's exactly what this 260 means. Use a rule to find the value of the investment after 15 years. All right, so first things first, got to come up with a rule. This here is a recurrence relationship. It's not a rule, it's a recurrence relationship. So we know that my rule is V of n is equal to, it starts with V0, 4,000. It's plus, because it's interest. Interest always gets added on. N times whatever my common difference is. And in this situation, it's 260. Right, so there is my rule. I want the value after 15 years. So what they're asking me to do is find V of 15. Right, well, if the n here changes to 15, then the n here also changes to 15. So that becomes 4,000 plus 15 lots of 260. No way I can do that in my head. So let's see what comes out there. 4123 plus 15 times 260 gives me $7,900. So there you go. That is going to be the value of the investment after 15 years. Now again, if you look at this here, that 15 times 260, that sort of makes sense. I'm paying in $260 each time for 15 years, and I'm adding it onto my initial investment of $4,000. Use a rule to find when the value of the investment first exceeds $10,000. Now there's lots of ways of doing this. I could just keep hitting enter, but there is an algebraic way we can do it. What we now know then from our rule is, let's see how long it takes for this value here to become 10,000. So I'm going to replace V of n with 10,000. So 10, 1, 2, 3 is equal to 4,000 plus n times 260, because n, if you remember, is the number of years. That's what I'm trying to find out, that value of n. Now again, I could do this algebraically, but sorry about the way I've left my calculator on. So let's just make that clear there. So 10,000 is equal to 4,000 plus n times 260, because I know that this number is in my sequence, or at least we hope it is. So firing up my calculator, I'm actually going to let my calculator do all the hard work. So I'm going to do algebra, solve, and all I do is put the equation in. So 10,123 equals 4,123 plus n times 260, hit comma, and then n, because you want to tell the calculator, there's my equation, find the value of n. And when I hit enter, ooh, hold on a moment, what do I get there? I get a negative value. And that's because I've entered the wrong number in. I do that all the time. So again, that looked wrong. And thankfully, the reason it's wrong is because I missed a 0 off. Now, if we look at that value there, we get m is equal to 23.0769. And this comes down to whether you can understand the question. All right, because it says actually it wants to know the value of n when it first exceeds 10,000. I'm not going to put money in a bank for 23.0, I've covered it again, for 23.0769 years. It doesn't make any sense. All right, so I can't write 23, because if I write 23, it's going to be less than 10,000. Right, so I actually have to write the next value bigger. And so in that situation, it would be after 24 years, because if I put 24 years into this equation here, then I will actually get out 10,000 and some sort of number. Okay, a lot to learn. Don't forget, you can stop this video, go back, rewind it, listen to it again, anything that actually makes sense. The following recurrence relation can be used to model a simple interest investment of 12,000, paying 4.8% per year. Notice they're just changing the figures. Again, it's another simple interest, $12,000, 4.8% per year. There's my V0 of 12,000. Where did I get the 576 from? 4.8 divided by 100 times 12,000. That's going to give me 576, I promise you. How much interest is added to the investment each year? Hold on a moment, exactly the same. It is going to be $576. Use a rule to find the value of the investment after 10 years. Well, we know the rule is going to be V of m is equal to V0 plus n times d. Why is it plus? Again, why is it plus? Because it is simple interest. Simple interest means we are adding on. So that gives me the v of n is v0, which is 12,123, plus n times, what's my common difference? 576. We wanted to know after 10 years, so we're going to find v of 10, which gives me 12,123 plus 10 lots of 576. If you're wondering what that dot is there that I keep typing or doing, that's basically a time sign. In the UK, we've been told that if you put a dot down on the line, it's a times. If you put a dot in the middle, it's a decimal place. So hopefully that hasn't confused you with everyone going, why does he keep doing a dot? It's not a decimal place, it's a times. All right, sorry, I get a little bit too excited when I'm doing this type of stuff and I revert back to my English ways. So if I do 12,123, I'm going to add on 10 times 576, hit enter, gives me a value of $17,760. Ka-ching! Use a rule to find when the value of the investment first exceeds $20,000, exactly the same as we did before. They're now basically giving me a value of the investment. That's VN, that's the value of my investment. So I now know that we're looking for V of N to be 20,000. So 20,123 is equal to, what do we have? 12,123 plus N times 576. So leaving that on there, I can't solve that in my head, so I'm going to fire up my calculator to see what I can do. So again, I'm going to do solve. 20,123 is equal to 12,123 plus N times 576, comma N, don't forget the comma N, and again, it's going to give me a decimal value of N, 13.888. And so it goes on. Well, I can't leave that as an answer because, again, I can't take my money out at 13.8888888. So I've got to round it. If I round it to 13, if I round it down, I'm stuffed, okay? Because 13, and again, try it. If you put 13 in that value there, this will not come out to be 20,000. It'll be just below 20,000. So in which case 13 won't exceed 20,000. So in which case my correct answer in that situation would be N is equal to 14 years. These things really do take practice just to get your idea around what simple interest is and how to do this. These really do take practice, and practice, they do say it makes perfect, but thankfully that's the end of this video. And there we go, that's the end of this video. Thank you very much for watching. I know it was a bit of a long one, sorry about that. There's a lot of stuff in this particular exercise, but hopefully it's been useful. All right, please head over to YouTube and subscribe if you can. Follow me on TikTok and all that jazz. Otherwise, I look forward to seeing you in another video. Take care, guys. Bye-bye.